All right, we're going to look at sum and difference formulas today, and along with double angle and half angle formulas. Now, these are all in our identity sheet that I gave you in formula sheet. You'll notice that the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So how do we find the exact value of cosine of 105? Well, we're going to use the formulas. So the exact value of 105, let's see, 105 would be 90 minus 15, but we don't know what 15 is. How about 60 and 45? That would add up. So alpha plus beta, in other words, we're going to use this formula. So if we make alpha 60 degrees and beta 45 degrees, then we can go cosine of 60 plus 45 is equal to, and using the formula, cosine 60 cosine 45 minus sine 60 sine 45. And that just comes straight from the formula that I'm looking at on our sheet. Okay, well, need to get this a little darker. What's the cosine of 60? 1/2. See, we cannot forget these. Radical 2 over 2 minus, let's see, the sine of 60 was radical 3 over 2. The sine of 45 was radical 2 over 2. Well, then that leads to radical 2 over 4 minus radical 6 over 4. Because we can multiply 3 times 2 because they're both in the radicands. We cannot subtract them though. So the cosine of 105 exactly is radical 2 minus radical 6 all over 4. Okay? Now these cofunctions identities just mean, like, what this means is the cosine of 90 is equal, or the cosine of 40 is equal to the sine of 50. Those are cofunctions. And I've got a phone call, but I'm going to ignore it, and I'll get back to that later. All right, now the sine of alpha plus beta and the sine of alpha minus beta are those formulas. So how do we find the exact value of sine of negative pi over 12? Well, the first thing I would do, if I were you, is I would say, okay, that's negative 15 degrees, because it's way easier to work with degrees on this. Okay, so what gives me negative 15? Well, how about 30 minus 45? Now, there are multiple ways to do this, okay? But I'm going to use 30 minus 45. So if I use this formula, I'm going to use the minus one up there. So I picked 30 to be alpha, 45 to be beta, and we evaluate. What's the sine of 30? 1/2. Cosine of 45. Let's see, the cosine of 30 is radical 3 over 2. The sine of 45 is rad 2 over 2. That's radical 2 over 4 minus radical 6 over 4. And guess what? We got the same answer. So the sine of negative 15 is the same as the cosine of 105. Interesting. Radical 2 minus radical 6 all over 4. Okay, how about some sum and difference formulas for tangents? Well, there are those two formulas right there. Let's do the tangent of 75. Okay, I think 30 plus 45 would give me 75. Okay, now I don't have these memorized. So that's the tangent of alpha plus the tangent of beta over 1 minus, I believe it's minus, yep, tangent 30, tangent 45. Okay, So now we just evaluate. The tangent of 30 is radical 3 over 3. The tangent of 45 is 1. So we just fill that in here, and we try to simplify. Hey, you got to get a common denominator. Well, that's going to be a 3. So that's going to be radical 3 plus 3 all over 3. Over here, we got to get a common denominator. That's going to be 3 minus radical 3 all over 3. So if I simplify this, or try to, I'm going to multiply by the reciprocal and get radical 3 plus 3 all over 3 minus radical 3. And you can leave it like this because I said you can. We could multiply by the conjugate and get rid of the radical in the denominator, but for time constraints, we don't have that luxury.